Hello and welcome to the PML school. I'm happy to see that the interest in our little webinar series is still pretty high, so this is encouraging. So we will continue with the series and we will produce new content, and also we are trying to keep this webinar running on a bi-weekly basis. As we promised last year, this year we will be starting with a new series where we want to look at non-MEM models. As you know, non-MEM is a popular modeling package, and with our new series we want to demonstrate that you can build those models easily in Phoenix. That's a modeling package that you should be familiar with now. So the focus of the presentation and the demo that I will be given is to give you a hands-on tutorial on these models. All non-MEM models are first of all textual models, but they are also population models. That means instead of trying to fit data on an individual basis, say profile by profile, population models try to fit the data of an entire population. And here the population often means that all individuals of a particular study. And the ultimate goal of a population modeling is to identify trends in the data, such as changes in clearance or volume with changes in age or weight. So for our webinar, we have to assume that you have some basic knowledge around nonlinear mixed effects modeling, because this we cannot cover in our PML school. If you think you would need some more background or you would need a refresher, I would recommend a course at our Certara University. And I will provide a link to this at the end of the presentation. There you will also find courses for beginners. So I'll jump the slide. We have been working on these non-MEM to NLME comparisons for a while now. And as you might have noticed, we have already started to upload quite a few of those models, those comparisons to our forum. Here's the link. And so far we have posted 26 different models. We still have 40 to 50 models that we are currently working on, and those get uploaded to the forum over the year's time. But for now, we are focusing on a first set of 4 non-MEM models. So this is the schedule of our initial series. Today I'm showing the introduction to non-MEM to NLME, and with a very simple and straightforward model, which is a one-compartment IV Bolus model that is solved with the FOCE method. Focus of today's session is less on the complexity of the model itself. Essentially, it's the simplest model you can think of. We will focus instead on the overall process. Where we start with this, what are the steps to run the models, and finally, how can we compare the results side by side. The next session is in 2 weeks' time, where I'm showing a bit more complex model. This is a 2-compartment model with multiple doses and with plasma and urine data. And here the method is the QR-PEM-IMP method for solving. And then, in the beginning of March, I'm more than happy to present a new speaker in PML school. My colleague, Venkateshwari Muthukrishnan, she will talk about a 2-compartmental model with a covariate. The last session in this mini-series is conducted by Lone Pham from Camargo. You know her already. She gave an excellent PML school presentation on a mini PBPK model last year. So in this series, she will be presenting how to translate a TMDD model from non-MEM to NLME. So here's a typical agenda for this series. And we will always start with a short model description. Then we do some initial data exploration. We will take a look at the input data for the model, but the main part of the presentation will be the review of the model code, where we present the NM trend code side by side to the PML code. There is no direct translation possible between these two languages, but there are a few patterns that you will see will pop up frequently when you move from one to the other modeling language. And that should help you learn how to translate these models on your own. After the code review, we will then proceed with a demo where I'm showing the two models in Phoenix, how to set them up, run them, and compare the results. We will then conclude with a summary and a Q&A session, and that's typically it. So we'll start now with the first NONMEM model, the one compartment IV Bolus model, and here we assume first order kinetics, and we parameterize with clearance and volume. For the error model, we assume log normal distribution of clearance and volume. We initialize our fixed effects, the typical volume, TVV, and the typical clearance, TVCL, with a value of 1 each. As a random effect, we assume a variance of 0.1, which corresponds to a population variability of about 30%. The engine or the method that we are using is FOCE ELS. This is for the fitting. So now, here's just a plot of the first patient on a semi-log scale. As you can clearly recognize, there's only one slope, so these data follow a first order kinetics, and our assumption about the model seems to be correct. Okay. So looking at the input data, typically with NONMEM and NLME input, you don't expect many differences. And as you can see here, that's the case here too. So the information in the individual columns are essentially identical. The column names might differ a bit, and that seems a bit arbitrary, but nevertheless, let's go through them one by one. Whereas, let me show the laser pointer, whereas a NONMEM speaks of a CID as an identifier column, NLME calls this simply ID. Time is time. DV in NONMEM means dependent variable. And this relates in NLME to the COPS, which means concentration observed. What you see here is an MDV column in both inputs. That means a missing data value. These are essentially the dosing records. And a value for MDV equals 1 means omit this concentration value. Whereas NLME ignores this record, except for the dosing part, obviously. NONMEM behaves a bit different as it sets dependent and predicted values for this time point to 0. Then we have another difference. This is a column for the dosing amounts. This is called AMT in NONMEM and A1 in NLME. This stands for IV input. Also, what you can see just that in the dosing and the amount column, in NONMEM you have some dots on these empty cells, and in NLME these are just simply empty where you don't have any dosing amounts. But that's about it. So the input data for the two equivalent types of models are mostly the same. So coming here now to the code itself. The code is a little bit longer. It doesn't fit on one slide, so I've split it up into 3 slides. And this is on the left-hand side. This is the in NONMEM. The model is coded up in what is called a control file. This is just a text document, and it's comparable to the PML code or the textual model in Phoenix. So what you see on the right-hand side is the textual model in Phoenix. And NONMEM uses a language they call NMTran to code models. So the control file starts with a subroutine record, $sub, where you define the methods that should be used for this fit. In this case, we are selecting the closed form. The corresponding method selection in PML is done by the CF micro statement, as you can see here on the right-hand side. And this CF micro closed form micro statement specifies A1 as the input, IV Bolus input, and clearance parameterization with CL and V. One difference in Phoenix, you would also need to specify a dose point. In this case, dose point A1 means this is the IV Bolus dose that we specify here. This is not necessary in NONMEM, and so this is just needs to be remembered. And the next part is the structural parameters, the $pk records. They specify the individual pk parameters. Here we have the fixed effects, TVV and TVCL. They are denoted theta1 and theta2. And the structural parameters, volume and clearance, where the structural parameters are expressed in product form with random effects in exponentials. The random effects are then here denoted as eta1 and eta2. The same in PML code. These are the ST-PALM statements. You just give it this equation, the structural parameter V equals, and it's here the same as a product form of the fixed effects with the random effect in exponential. And the same for clearance as well. Next slide is the closed form in equation calculates the amount of drug in the central compartment. And we need a scaling parameter to return concentration. In NONMEM, this is simply put in like this, like S1 equals V. The equivalent in Phoenix is C, the concentration, equals A1, the dose amount, divided by V, the volume. Okay, we also need some initial values, initial estimates for theta and omega. And these are set here in the $theta and $omega records, like here. And the same, the equivalent in PML code would be the fixEF and RANF statements. That's shown here. Obviously, the RANF statement is equivalent here with a diagonal structure of the omega matrix. And we have here the initial values, which is 1 for the fixed effects and 0.1 for the random effect. Oops. The next one. This is the final part of the code. And here the residual error model is specified. In NONMEM, the initial estimate for residual variability is expressed as variance, or sigma squared, with a value of 0.01. Corresponding PML code would be the error statement, where we specify CEPs, then this is equals to 0.1. Here the variability is not expressed as variance, but as standard deviation, so that's why you see the difference in the value. Then the error term gives you the expression for the prediction, and the f is a prediction variable, and 1 plus epsilon, this is a residual error, this is a multiplicative residual error. And the equivalent statement in Phoenix would be observe, the observe statement. C-ops is then equals the predicted concentration multiplied by the same term, 1 plus C-eps. Then I've added a few lines that I needed to do the comparison with Phoenix NLME results. So I specified IVA, independent variable, this is equals to time. The individual prediction, this is actually F from the last equation. And the individual residuals, these are just the observed DV, dependent variable values minus the individual predictions. This can be then written out into a separate sheet, and we can use it to compare the results. So this is just the code, these 3 slides. And on the next slide, this is just to want to remind you how you would set up the same model in Phoenix. You know that for this simple model, we don't need to write PML code. We just need to use the built-in options. So this is our usual bottom panel of the Phoenix model object, where we keep, in this case, the population box checked because we have a population model in this case. The type of model is a PK model, and the parameterization is clearance. Absorption is intravenous, and we only have 1 compartment, so all default. We are using, actually, in this case, a closed form. So we want to be as close as possible to NONMEM. But we need to switch to a multiplicative residual error model. And a default standard deviation is 0.1, so this is what we take. And the same thing, I mean, we don't need to do any changes on the model. This is a graphical depiction of the same model, and this is a representative PML code. This is the same as you get from the built-in options, and that is really what we just discussed side by side with the NMTran with the NONMEM code. Okay, that's all what I have on the model. Let's go into the demo now. Okay. Cheryl, can you see my screen?
Yes.
Okay, so we are in Phoenix, and this is a new project, live session, where I've got 2 data sets imported that we just looked at. This is an NLME input, as we've just seen on the slides, and the equivalent one for the NONMEM is this worksheet. So what we need to do in order to run a NONMEM job, we just need to send this to a function you find here under NONMEM. That is a NONMEM shell. And what the NONMEM shell is doing, you can set up your NONMEM run from here, and then you submit it to run outside of Phoenix. In order to do that, you need to have under Edit Preferences, you see this under Preferences, there's a NONMEM section where you need to, obviously you need to have a local NONMEM installation, and you have to provide the path to the batch file, nmfe73.bat, for example, in my case. Then you can, specify a default output folder, then so that it can create a unique subfolder for each run that you launch from Phoenix. So this is a data set. Now we need a control file. This control file that I showed on the slides, this is typically an ASCII file. It is shown here. That's exactly what we talked about. So we just take this into this empty box. We just move it over here. This is our model, encoded in NMTran. And that's all what we need to do. Let's look at the mapping. It identifies the mapping with the exception of the CID column, okay. So everything is prepared for the run. So I just need to execute, and it will submit this job to a NONMEM exe, to the NONMEM batch file, and it will run, as you see here, from the logs. It compiles and runs iterations and feeds back all the results into Phoenix. So we got a lot of files now coming back from this NONMEM run. There are some worksheets containing some results. Here, for example, we have the omega metrics, the standard errors for omega, the fixed effects, and the structural parameters. And here we've got an extended list of residuals. And this looks very much very close to the residual sheet in NLME. Then we've got some sigma and tables, the summary table, theta, all the results, and also some plots, like the observed versus predicted, and some residuals. This is the result, and we want to compare this now with a Phoenix model. For this, we just need to go back to our input data and send this to a Phoenix model object. And as we just said, I mean, we just can't focus here on the bottom panel, where we say, okay, population, PK, clearance parameterization, intravenous absorption, one compartment, stick with a closed form, and we switch here to multiplicative. And you see the default value is 0.1. Then we have this MDV column, the missing data value. So we need to go to input options and check this box on MDV, and it will now map here in this case. The random effects, we need some initial, the initial parameters, initial estimates for the fixed effects are 1 and 1, so we don't need to change this, but the random effects we need to change to 0.1 for both. And then what we see here under run options, the default algorithm is FOCE ELS, so we'll stick with the defaults here and are ready to run. Just to present this is a graphical model of the this IV one compartment IV bolus. We can switch directly to the textual one, and you see these are the identical PML statements that we just discussed on the slides. So we just say off start, and then it runs some 10 or 15 iterations, and back we've got the results, eta values, the overall sheet, some postdoc parameters, and here all the residuals. Theta, some plots, like some histograms, and some residuals versus time or versus predicted values, and so forth, lots of plots. So now the question is, I mean, how can we compare it side by side? And for this, I actually created a simple workflow that I can load into this project file. And this is just prepared, so I can load it into my project at any point in time. And okay, it takes a while to load. But this is a comparison workflow where we need to create joint worksheets for eta, for theta overall, and the omega as well as a residual sheet. So this will just need to be merged together. But merging alone is not enough. We need to do a little bit more steps. But in order to complete all the individual parts of this workflow, it's a good idea to link, the results from the two models via data links to this template workflow. And so what we have here, these are the data links, just making sure that the input is properly linked with the rest of the workflow. So for example, Theta NLME asks for the theta table from the Phoenix model, and this is here, and you see it finds all the required columns. Same for sigma, and now I need to go through this a little bit of work. Sigma SE, this is here. Sigma from NONMEM is here, and so forth. I need to go through this a little bit. Take theta SE, this one, and theta NM. So let me finish this one shortly. The problem with, or it's not a problem, what you need to know is that the results from NONMEM are split over several spreadsheets, so the standard errors always come separately. And omega NONMEM, and this is different from NLME, obviously. Okay, residuals NLME. This here. Bear with me for a moment. This takes some time. Overall NLME, yes, is equivalent to summary in NONMEM, and the ETAs from the NLME model a little bit down here, and that is equivalent to the control file here in, control file here, control file phi. Okay, so we've linked now the comparison workflow with all the results from the two models. Now we can just execute it. So what it does now is it's taking the individual sheets. What it needs to do is to append records, rearrange columns and rows, and also do some renaming in order really to be comparable. But that is all processed in these individual sub-workflows, and what we end up with is a report. So you see at the bottom of the process, or here on the right-hand side, the reporter object. This will summarize all the results. It will put everything into a Word document, and this you can then examine in all detail. So once it's finished, we can just go to this reporter object, and it shouldn't take too long now. Okay, so let's go to the reporter object, and here everything is summarized in one Word document. If I open this up, you see you've got a few tables like the theta table, where you've got the different sources, NLME and NONMEM model, and the estimates in the standard errors. Same for the ETAs, values, random effects. You've got the omega table and also the plots side by side. Here's a conditional weighted residuals histogram, and here are the 4 eta histograms. And as you can see, I mean, they look pretty much the same, maybe small differences. Here are some residuals versus time versus predicted values. It looks very nice, and always much the same between the two different programs. And finally, you've got also the plots, the fitted plots, either as a spaghetti plot or as a trellis plot. And that's what you can see here. Okay, let's go back to Phoenix. What we did in these sub-workflows, I mean, I can show you maybe here with the ETA workflow. What you need to do, first step, is to append the two results, one from NONMEM and one from NLME. So you've got them in a merged worksheet. Then in the preparation step, you have to assign the source name for NLME and NONMEM for those records. Then this next one, stack etas, you stack them up so that they are really in individual, in one column, in one eta column, and then you can go to this one and have one final table that you can then link with the reporter object so that it will show up there. The same you can do, for example, with a residuals worksheet, append residuals and do some naming, and then you have the plots where you just, where you just specify as a source, you put it on a lattice condition column, and then you can watch them side by side. The histograms for the conditional weighted residuals and the ones for the etas, for example, here, but also all the other plots here you can watch side by side. Okay, as you know, I'll upload this project file and the template file at the end of the session to the forum, so you can pick it up there and you can play around with these workflows if you want. That's the end of the demo. Let me go. Next slide. Just once again, the results. What you can see here is really that there are really just small differences here on the plots. Almost no differences between NLME and non-mem result. This is also reflected in the theta table, in the overall table. What you see here, sorry, this is a theta table with clearance and volume estimates and standard errors. And this brings me to the end of the presentation. I just want to summarize what we did today. So we set up and run a non-mem model that we could launch from Phoenix. This is one compartment IV Bolus. And we set up and run the equivalent model in Phoenix NLME. Then we post-processed all the results and compared them side by side, and we could see that there are only small difference between the two. That's the end of the presentation. Now let's go to Q&A. Let's see what we have. Yes, I don't see, I just see one. Yeah, I just one. What does CF micro mean? CF micro doesn't mean a dose. It means this is a specific statement that specifies the closed form equation for the solving the model, the fit, and this has just the central compartment A1 as an IV bolus, and how you want to parameterize it in this case with clearance and volume. That's what it means.
There's also a question in chat.
Okay, let me see. I guess I don't see this one. Sarah, can you maybe read it for me?
I will try. Is there a function in NLME that I can run several models sequentially? For example, I have 3 models that may hours to run. I'm not sure what it means, but I do not know exactly when each run finishes. I want NLME run my first model first after the first model finished. NLME will run the second model after the second model finished. NLME will run the third model. How about non-mem? Does that make sense?
Yeah, makes sense. Yes. We have you can run NLME models from the command line. So you just need to open a DOS shell in this case, and just run them. You can set up a script for this to run sequentially, but you can also execute them one by one from within the shell. So this is possible.
Okay. And then another question is, will you also present in future about covariate selection using Phoenix NLME?
Yes, actually, what I said in the beginning, one of the sessions, the third one actually, given by Eshwari, we are presenting a model with a covariate. And so we will deal with that. If that is of popular interest, I mean, we can also spend some more time on this. We just need some feedback from the crowd. I mean, how important, how interesting this is, and we can create some content and provide a separate webinar session for covariate selection in Phoenix.
Okay, and there's one more. Is the template you presented for comparing Phoenix and NONMEM, will it be available for users?
Yes. As I said, I mean, I will post it to our forum at the typical place, and I'll make available the slide material, also the recorded session on YouTube, and so you will have everything at your fingertips. I mean, you can download it from there, and it's free material.
Okay, that's it. Thank you.
Oh, all right. Good. Thanks, Cheryl. Just one thing I mentioned at the beginning, maybe you don't have enough background or you need a refresher course in population modeling. Certara University is just there for this. I mean, they offer a wide range of courses from the beginners over intermediate levels to advanced levels, and this also covers population modeling. So I would just encourage you to maybe visit this site, www.certarauniversity.com, to find out more. And with that, we are pretty close to finish. So coming up, please mark your calendars for the next session of this mini-series. In 2 weeks' time, I'm going to present the 2-compartment multiple-dose IV bolus plasma and urine model which is fitted with the QRPEM IMP methods. Okay, with that, at the end, thank you very much for your attention, and hope to see you in 2 weeks' time. You may want to disconnect now.